Okay, it's a graphing question. Complete the table for the values 3 divided by x. Now, don't think anything of it, just whatever your x is, do 3 divided by that number. So this one here, I'm going to do 3 divided by 0.5, which gives me 6. You might not even understand why that's 6, but just trust me. That one there, 3 divided by 3. I know what 3 divided by 3 in my head is, but I'm using my calculator just to make sure. Then 3 divided by 5, 0.6, and 3 divided by 6, which is 0.5. Okay, trust your calculator. Right, the next bit we've got to plot it. Okay, so x is 0.5 across 6 up, so it's 0.5 of 6. Next one's 1, 3, 1 across 3 up. Then it's 2, 1.5. 2 across 1.5 up, then 3 across 1, 4.75. Be careful, 0.75 is going to be halfway between your 0.5 and your 0.1. 5 and 0.6, and 6 and 0.5. Okay, I don't know why, but people always forget to join these up. They don't join them up with a ruler, try and get a nice curve going. Okay, and there you go. Yours should be a little bit better, just for the fact that you're going to use a pencil. Thank you. Okay. Gina finds out the price of CD box sets in 3 different countries. The price in the UK is £98. The price in the USA is $134.99, and the price in Germany is €139.99. Okay. Gina wants to pay the cheapest price for a box set. For which country should Gina buy the box set? You must show your working. Now, first of all, let's choose a currency. Now, I'm going to choose pounds. Okay. So I know in the UK, it's going to be £98. Okay. I don't have to do any working out for that. So all I need to do is work out how much $134.99 is in pounds, and how much €139.99 is in pounds. Okay. Now, if you think about exchange rates, if I'm going across, I times it because that says 1. If I'm going the other way, I divide it. So let's do Germany first. Okay. So I've got 139.99. In fact, GRM. Okay. Euros. Now it's €1 equals 0.73. So I'm going to times this by 0.73. Okay. I can't do that in my head. I'm going to trust my calculator. 139.99 times 0.73. So in Germany, it's going to be £102.19. Okay, now I've got a little bit to compare by. Now the next thing I'll do is I'll work about America. And I'm actually going to put this in just so it's clear that that's what worked out for Germany. Now for America, it's $134.99. Now here, I've got £1 equals $1.43. Now previously we timed, because we saw it going right. So here we've got to do the opposite. We actually have to divide it by 1.43. Okay. So again, just trust in your calculator. Okay. 134.99 divided by 1.43 equals 94. Now this rounds up to 40 pounds. Okay. Now it's a bit obvious to see which one is cheaper, which is America. Sorry, USA. Okay, second part of this question. Why might your answer to A not be the best country for Gina to buy the box set from? Well, it's from America, so you have to say due to postage, essentially. See A. Okay, thank you. Okay, this is a direct proportion question. So the table shows values of x and y, tick the correct statement. This means y is proportional to x, that's y is proportional to x squared, y is proportional to x cubed. Okay, now let's just test this out. I'm going to first see if it's y proportional to x. So y is proportional to kx, and we need to find out what k is. Let's try it for the first one. So I've got 400 is equal to k times 5. To solve this, we divide by 5 divided by 5, which means k is going to be equal to 80. Now let's test it for the second one, and if it's true for the second one, then we know we've definitely got an answer there. So we're going to be y is equal to 80x. Let's test it. So we've got 576. Is that proportional to 80 times 6? So you can actually use a calculator. 80 times 6 is 480, so that's wrong. Okay, so it can't be that. So then we're going to have to try to see if k is proportional to x squared, which then would give me the formula y equals k x squared. And again, we're going to have to substitute the values in for first one. So k equals x is 5, so it's going to be 5 squared. We know 5 squared is 25. Okay, so to solve this, we divide both sides by 25. Right, to see if y is proportional to x squared, we do y equals k of x squared. Okay, substitute the numbers in again like we did last time. 400 equals k 5 squared. 5 squared is 25, so k times 25 equals 400. To solve for k, we divide it by 25 divided by 25. I'm going to use my calculator not to make any mistakes. 400 divided by 25, 16. So k equals 16. Same as last time, I need to substitute it in to the next one to check to see if it's right. So I've got y is equal to kx squared. So I've got 16 times 6 squared equals, I'll type it into my calculator. 16 times 6 squared is 576, which is that one there, which is 576. So it's going to have to be the middle one. Okay. Now, write a formula for y in terms of x. Okay. Now the formula here, which is y equals, we worked out k to be 16, x squared. Now this would be fine if it was in terms of y, but it's not, it's in terms of x. So we need to get x on its own. Let's get rid of 16, divided by 16, divided by 16. Okay, y over 16 equals x squared. To get rid of squared, we square root and square root. Okay, which actually means the square root of y over 16 equals x. Okay, if you want to make it a little bit simpler, 16 is a square number, so you can actually do the square root of y over 4, because the square root of 16 is 4, equals x. Okay, this one here says, right, 3.6 times 10 to the power 4 is an ordinary number. Easiest way is to 3.6, but times it by 10 4 times. So 1, 2, 3, 4. Put my zeros in. So my answer is going to be 3, 6, 1, 2, 3. But don't forget this is a calculator paper. So what I could have really have just done is 3.6 times 10 to the power of 4. And my calculator would have done it for me without any working out whatsoever. Okay, just zoomed out a little bit. Work out the value of 2.8 times 10 to the power minus 2 divided by 4.7 times 10 to the power 5. Give your answers in standard form, correct 3 significant figures. Now, this might go on a non-calculator paper, but these numbers are a little bit difficult. If I get my calculator, okay, the actual numbers I want to do is, so if I do 2.8 divided by 4.7, I actually get this big long number. So I'm just going to write it down. It was 0.59574. Okay. If we're multiplying it, it's going to be times 10, and normally, because that's division, we subtract the indices. So it's going to be minus 2 subtracted by minus 5, which is minus 7. Okay, but this isn't in standard form, because we need this number here to be in between 1 and 9. So if I make this number here 10 times bigger, I need to make this one 10 times smaller. So 5.95744 times 10. So again, if this is 10 times bigger, it's going to be 10 times smaller, which would be minus 8. Now it says give your answer to 3 significant figures. First one, second one, third one, which is there. So my 7 will push this up to be a 6. So it's 5.96 times 10 to the power of minus 8. Okay. Right, last note on this question. This calculator paper, you can just type this into your calculator. Now my calculator is not the best calculator, but if I wanted to, brackets 2.8 times 10 to the power of, negative 2. Okay, let's put it in brackets, divided by brackets 4.7 times 10 to the power of 5. I got this answer, but then I just have to convert this into standard form, and if your calculator is better, we'll give you the extra digit. Okay, this is a new style ratio question. Find the ratio A to B to C. Give the answer in the simplest form. Now, A is 8 and B is 5. Here B is 3 and C is 4. Now, what's stopping us from comparing it is that the B's, which are in both, are not the same value. So we need to make B's the same. Now, it's easiest if you go for the lowest common multiple of 5 and 3, but any multiple will go fine, as long as then we can simplify it. We know that if we times this by 5, it'll make 15. If we times this by 3, it'll make 15. So that's what we're going to do. So this bit here, we're actually going to multiply it by 3. Okay, so then it's going to be 15. 8 times 3, it's calculator paper. It's going to be lazy and use my calculator. 24. And this one here, we're going to times it by 5. 5 times 3 is 15. 4 times 5 is 20. So we can now make the ratio 24 to 15 to 20. Just make sure this can't be simplified. That's an odd number, so 2 don't go into it. 5 doesn't go into 24, 3 doesn't go into 20, so that's going to be it. Thank you. Okay, find an expression in terms of n for the nth term of this sequence. Right, I'm going to write the sequence out. Right, we'll check the first level difference. So the difference between 3 and 8 is 5. The difference between 8 and 15 is 7. The difference between 15 and 24 is 9. This tells me it can't be a linear sequence. So let's try the second level difference. Difference between 5 and 7 is 2. Difference between 7 and 9 is 2. That tells me it's quadratic because these are the same. Okay. Just remember, with the quadratic, your x squared term is always half of that, which is 1. So it's going to be 1x squared. If we write out our sequence, we actually get 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, now from this we write the formula underneath: 3, 8, 15, 24. Now we know, because this is quadratic, because we discovered through the second level difference, the actual formula is going to be x squared plus bx plus c, because this is a form of every quadratic formula. Now what we can do, if we subtract if we subtract one from the other, we're actually going to end up getting bx plus c, which is a nice linear sequence. Now it's a bit confusing, but I'm going to actually subtract 3 from 1 to give me 2. I'm going to subtract 8 from 4 to give me 4. 15 from 9 to give me 6. 24 from 16 to give me 8. Now this is a nice linear sequence. If we check our differences, we get 2. Right, because we know the common difference is 2. My sequence there is going to be 2x plus nothing. Okay, we've got the x squared. Okay, so my sequence is going to be x squared plus 2x, but because it's asked for it in terms of n, it's going to be n squared plus 2n. Second bit says the nth term of a different sequence is 2n plus 5. Show that 36 is not a term of this sequence. Right, 36 equals 2n plus 5. We try and solve it. So with minus 5 with minus 5 to make 31 equals 2n. Now this is a little bit confusing because we don't really have knowledge GCSE to solve this. But what we do know is that 2 to the power of something is going to be even. So you can say 36 is not in the sequence. As 31 is not even, and 2 to the power of n is. Given that 3 to the power of minus n equals 0.2, find the value of 3 to the power of 4 to the power of n. Now 3 to the minus n equals 0.2. I can't work with this because this is a decimal. I need to work with fractions. So to change this into a fraction is just 1/5. Equals 3 to the power of minus n. Now this negative n, what this means is if I wanted to get it to a positive n, I'd need to take a reciprocal 1/5. Now the reciprocal 1/5 is just 5 over 1, or just 5. Now we could solve for n, but we don't really have that knowledge of GCSE. So we need to sort of like change this question here a little bit. Now 3 to the power 4, all of it to the power of n, is the same as 3 to the power 4n, because we multiply when you do brackets. But it's also the same as 3n, all of it to the power of 4. Okay? We actually know what 3n is. 3n's here, okay, which is 5. So we know that's 5 to the power of 4. If you don't know what 5 to the power of 4 is, it's calculator paper, so it's fine. So it's 5 to the power of 4, which is 625. So your answer is 625. This is a ladder. It says the bottom of the ladder is d meters from the wall. The top of the ladder is h meters above the ground. The angle between the ladder and the ground is x. Some safety instructions say it's safe to climb a ladder when h equals 4d. Work out the angle when h equals 4d. Now, this is still a trigonometry question. If we label our triangle up, this is your hypotenuse, this is your opposite, this is your adjacent. So we need to know which trig formula has the adjacent and the opposite. So it's actually going to be tan. Tan of the angle equals opposite over the adjacent. Okay. Tan of the angle. Now we don't know what opposite. I'm going to put h. Adjacent. I'm going to put d. You might think this doesn't help us, but we actually have a value for h, which is 4d. So I can put 4d. Okay. This actually then just cancels down to 4. So I have to use the tan of -1 of 4. So you do your calculator, make sure that it is in degrees. So which is tan of 4 equals 75.963. Okay, second part of the question is some different safety instructions say the angle between the ladder and the ground should be 75 degrees. Ladder is moved, so it's x equals 75. Now, if I do a little drawing, let's say it's like this, then I move it up, so it's like that. The height of the ladder is going to be increased, so say the height is increased. Okay, I've just done all this working out, but there is an easy way. If we go back right to start, okay, we know this is a quadratic sequence, so it's going to have something to do with n squared. Okay, so I'm actually going to write the square numbers, which are 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. I'm going to write this one again, 3, 8, 15, 24. Now, you want to look, see if there's a pattern between this number and that one. Now, the first one you notice is that this is like -1 from that. That is -1 from this. So we know if we get this n squared, we're going to have to subtract 1. So we're going to have to subtract 1 to get here. Okay. Second thing is, this bit here we're going to have to square to get this number. But the issue is, obviously, this is where n is 1, this is where n is 2, this is where n is 3, this is where n is 4. Okay. So really, for my second sequence, I want it to be my first, and my third value of n, I really want it to be my second. So really, all I need to do is to get this to be like 1 ahead of it. I'm just going to do n plus 1, and then we square it all and subtracting 1. And if you know your algebra, this answer is exactly the same as the other one if we completed the square. Alex wants to find out how many ducks there are in the park. One day he puts a tag on each of the 30 ducks. Next day he catches 40 ducks. 8 of these ducks have tags on them. Work out an estimate for the number of ducks in the park. So this is actually a ratio question. Okay, if we think about it, 30 have tags on out of the total. Now we don't know what the total is, that's what the question's asking us. But we do know that he's got, when he caught the ducks, he had 8 with tags on. Okay, so that's out of a total of 40. So now we have to ask ourselves, how can we make an equivalent ratio from 8 to 30? Now, 8 doesn't actually go into 30, so what we need to do, we need to go by a different number. A number that will always work will be 1. There are other numbers we can go by, but 1 would be nice. How do you get from 8 to 1? You divide it by 8. So I need to divide 40 by 8. 40 divided by 8 is 5. How do you get from 1 to 30? You times it by 30. So I need to times my 5 by 30, which is 150. Okay, next bit of a question is, Alex assumed that none of the tags fell off during the night. If Alex's assumptions is wrong, explain how this could affect your answer to part A. Now, let's say he's wrong. Okay. Let's say that instead of 8 people, let's say that there were 16 ducks. Okay. So he's assumed none of them have fallen off. I've assumed that 8 have fallen off. Now, if we do the same thing, he would have to divide by 16, yeah, which would be 1 to 2.5. Then we'd have to times by 30, which will make it 30 to 75. And if you see in this case, the actual ducks are actually less. So the actual answer is the amount of ducks will be less. Okay, this is a maths question. Shade the region that is divided by all these inequalities. Okay, x plus y is less than or equal to 6, y is less than or equal to 0, y is less than or equal to x plus 2. Okay, she did this for homework. The question is actually, Helen made some mistakes when she answered these questions. Write down the 2 mistakes. Now, the mistakes are either going to be the lines are wrong or the wrong version is shaded, or there's no dotted lines. Now, all of these are equal to, so it should be solid lines, so that's not it. So it's either that some of the lines are wrong or that the inequalities are wrong. So let's look at this one here. Y is less than or equal to x plus 2. Let's try and identify this line. So I'm going to do my table of values here. X, Y. I'm just going to choose some random numbers. 1, 2, 3. 0 plus 2 is 2. 1 plus 2 is 3. 3 plus 2 is 5. Let's just see if these are actually on my graph. 0 and 2 is here. Okay. 1, 3 is here. 2, 5. So this one here is y is less than or equal to x plus 2. And we'll test later to see if it's on the right side. Y is greater than or equal to 0. Now, you might think straight away that's your y-axis, but it's not. It's actually your x-axis. So it's actually this one here. This y is less than or equal to 0. Y is greater than, or equal to 0. Now, this is probably where a bit of a clue is, because if you think it's greater than, it really should be maybe this bit here, or that bit there. Either way, this bit of the shading is wrong, which is a bit of a big clue. Okay, next one, x plus y equals 6. So I'm actually going to do my table of values here, x and y. It's a fairly easy one to do, but I like to do the cover-up method where I choose x as 0, which means y's got to be 6, and I choose y as 0, which means x has got to be 6. Let's see if this is on a graph. 0, 6 is here, and 6, 0 is there. Now, it's fairly obvious that that isn't on, this line's not correct. This line should really be down there. So that's the first one that you have to put. So you've got to put x plus y is less than or equal to 6 is not drawn correct. Next thing, we've got to think about the shading. Now, as I said, the y is greater than 0 is a bit of a hint. But let's see if it's on the right side of the y is less than or equal to x plus 2. Now, you can choose whichever point you want. I always like choosing 0, 0, just because your maths becomes a lot easier. So let's just substitute into this equation. My y is 0, my x is 0, so 0 plus 2 is 2. Y is less than or equal to 2, which it is, which actually means this bit here is right, not that bit. So it'd actually be all of this bit here is shaded. Okay. You don't have to shade it for the question. So here I'd have to put in the y less than or equal to x plus 2. The wrong side is shaded. Okay, this is not an easy question. AB is chord of a circle with centre O. The radius of the circle is 30 centimetres. Angle AOB is 80 degrees. Work out what percentage of the area of the circle is shaded. Now, there's quite a lot that we need to do here. To find this little bit here, okay, we need to first find the whole sector. Then we need to find this triangle. Okay. Then we need to subtract it away. Now, it's not asking you what is the actual value of it. It's actually asking what percentage of the area. So then we have to work out the percentage. Now, first thing we work out is the sector. which is the angle over 360, okay, which is your area of your sector over your area of the circle. Now, area of circle is obviously pi r squared. Okay. Now, the angle is 80 degrees, that's really what we know. 360 is 360. And I always like working from the first principles. So it's like the angle of the sector and then the area of the sector over the total angles over the total area. Area of sector we still don't know, so I'm just going to put area of sector. Now we do know what the area of this whole circle is, which is pi r squared. Pi, the radius is 30, so it's 30 squared. To solve this, we times them both by pi 30 squared, which will give me 80 over 360 times pi 30 squared. Okay. If you type all of that into your calculator, you get 200 pi. I'm going to leave this in terms of pi. Okay, now I need to work out the area of this triangle. Okay, because these are both radius, they're both the same. So this is 30 centimeters. This is 30 centimeters. You might think this line here is 30 centimeters, but it's not the case. Otherwise, it'd be an equilateral triangle, which would make it 60. So it can't be. We need to work out the area. So we could do height times base divided by 2, but we haven't got height or a base, so it's a bit unhelpful. So we do the half AB sine C rule. Okay, half A is 30, B is 30, sine of 80. Okay, if you type that into your calculator and make sure it's in degrees, so half times 30 times 30 times the sine of 80 gets a big number. Now I'm going to write this all down just for the sake of accuracy. You might be able to get away with 1 or 2 decimal places, but there's no reason why not. Okay, what we need to do now is to get all of it, which is 200 pi. Okay, subtract it from this big number, 443.1634889, and that will give us the area of this little bit here. So it's calculator paper, so I'm going to do it on the calculator. So 200 pi minus 443.1634889. I'm just doing it for accuracy. I've got 185.1550418. Now it's just this little bit here. Okay. So that would be the area, but it doesn't want the area. It's asking for the percentage of the area shaded. So if this is just that little bit, to find out the percentage, we divide it by the area of a whole circle, which we've already worked out, but I'm going to write it as pi 30 squared. And then whatever that is, we times that by 100. I've already got this long number in my calculator. So I'm going to divide it by pi times 30 squared. Okay, gives me that, and I'm going to times it by 100. Okay, which gives me 6.5, I'm going to round to 2 decimal places, percent. That 8 pushes up to a 5. Okay, question 19. P has coordinates -9, 7. Q has coordinates 11, 12. M is a point on a line segment PQ, such as PM to MQ is 2 to 3. Line L is perpendicular to the line segment PQ. L passes through M. So I'm just going to draw out what's going on here, because this is a little bit hard to understand. Okay, so I'm just going to do some x's. I'm going to think -9, 7 is roughly about there. We'll put -9, 7. I'm going to label it P. Q I'm just going to put here, because I think this is roughly where it should be, which is 11, 12. I'm going to label that Q. Now it says this is a straight line. It says M. I'm going to use a different colour for M. It is here. It could be anywhere on this line. I'm just putting there just because I can. It's on a point segment, so that PM to MQ is 2 to 3. So on my line segment, this bit here will take out 2 of it, and this bit here will take ratio of 3. So this will be 2/5. This will be 3/5, if you want to think of it like that. Okay. And then what we have to do is it's going to be perpendicular, which means this is a right angle. So we have a line through this, and the question really is, what is the equation of this line there? Okay. So the first thing we need to do is we need to find the gradient of this line here, because then we know that the gradient of the green line is going to be the negative reciprocal of it. So I'll draw my triangle. Okay, Now I work out my height, and then I work out my base. Now if I look at my x values, it's starting at -9, and it's going all the way up to 11. Okay, that means my base is going to be 20 centimeters, well 20 units long. Okay, if we're looking at a height, we know it's starting at 7, and it's going up to 12, so that's 5. Now I'm going to write my 5 there, just because it reminds me that 5 divided by 20 is my gradient. So my gradient is going to be a quarter. Okay, a quarter of this line. Now remember that, because if this is a quarter, that means that my gradient for my line there would actually be -4. Okay, so I'm just going to put a circle around that because we're going to need that a little bit later. Second thing we have to do is work out what M is. Now I'm going to change colours. So point M. If we know that it's going to be 2/5 and then 3/5, we can work out this little bit here. Now 2/5 of 20 is 8. So I just know it's going to be 8 away from -1. And the height here is 5, which we've already stated. And 2/5 of 5 is 2. So I know it's going to be 2 up from P and 8 along from P. So -9 add 8 is your -1 value. So right there, -1. And your 7 plus 2, so 9. And this is your coordinates for M, -1, 9. Now let's put into the equation for the second line. Notice I'm not working out my equation for the line P to Q, because I don't need to. I don't care about the y-intercept for this. But let's talk about the second equation. So it's y equals mx plus c. We've already worked out what m is, because it's -4, because it's a perpendicular, the negative reciprocal of the other line. Now we need the coordinates. We have one set of coordinates for the green line, and that's for m, which is your -1, 9. My y value is 9, so I've got 9 equals, my gradient is -4. Okay, x is your -1 there, so times -1 plus c, and it's just an equation we have to solve. -4 times -1 is 4, and we -4 from both sides. Okay, to give us c, 9 minus 4 is 5. Okay, so 5 equals c. So my equation ends up being y equals -4x plus 5. Okay, question 17. Here is a speed time graph showing the speed in meters per second of an object t after it started to move. And the question says, use 3 strips of equal width to find an estimate for the area under the graph between t equals 1 and t equals 4. Okay, so t equals 1 is here. Okay, t equals 4 is there. Now we need to find all of this area. Now it's an estimate, which means that we can't work out exactly. So what we have to do is we draw some trapeziums. Now if you look up, there is a trapezium rule and there's something called differentiation, which you normally use, but we're just estimating. The first bit is 3 strips, so it's a little bit easier. Now I don't really know what these shapes are, so we've got to make them shapes that we know. So I'm going to join these up, and then I'm going to join those up, then I'm going to join those up. Okay, now I've got 3 shapes that I can deal with. If I turn them this way around, you realise I've got 3 trapeziums, yeah, which we can work out the area to. Now I'm going to label this as 1, 2, 3. Okay. Now, if you remember your formula for trapezium, it's top plus your bottom times your height divided by 2. Top and bottom in a lot of formulas are normally a plus b. It's something you have to remember. Okay. Now we get the measurements for the top and bottom of each of these by reading off a graph. So this one here, the top is 3.5, plus at the bottom is go along, I'm going to say 6.1. Okay, my height is 1, because from there to there is 1. All of this is divided by 2. Okay, and if I type this into my calculator, 3.5 plus 6.1 equals times 1 divided by 2 equals 4.8. Okay, the second one, my height is going to be 6.1 again. Okay, and my second bit is going to be 8.2. I'm going to times it by 1 and then divide it by 2. Again, there is no point times it by 1, but I'm just doing it just for the sake of it. That's 8.2 divided by 2 equals 7.15. Okay, my last one, height will be 8.2, is that one there? Okay, my second point, if you go up and you go across, that's 9.6. Sorry, times by 1 divided by 2. Let's do this. 8.2 plus 9.6 divided by 2, 8.9. Next bit we have to add these together. Because it's calculator paper, I'm going to take no risk, I'm just going to do it using my calculator. So 8.9 plus 7.15 plus 4.8 equals 20.85. And again, this is only an estimate, so you will have a range for your answers. Okay, second part, describe fully what your answer to part A represents. Now, what is the bit underneath the graph? Now, essentially, it is just your distance. Now, let's say I just drew a different graph on top of this. Let's say this one here that goes for 8 for 1 second. It makes sense. If I travelled for 8 meters per second for 1 second, I would have done 8 meters. So it really is a distance. Looks like the distance travelled. The second bit, explain whether your answer in part A gives an underestimate or an overestimate. Now, because it's not all the area, there is like this little bit here I haven't worked out, this little bit here I haven't worked out, this little bit here I haven't worked out. You have to say that it's an underestimate. As there is some area under the graph missing. Here is a sketch of part of the graph of y equals to pq to the power of x, where q is greater than 0. Okay. The point 0.05, 2k and 405 are all on the graph of y equals pq to the power of x. Find out the value of k. Now, when you first look at this, it's a ridiculously complicated question, but let's just start by substituting values in. So I'm going to start with my first point and just see if anything happens. So y, we have a value of y, which happens to be 5, equals p, I don't know what p is, q, I don't know what q is, x is 0. Now something nice happens, because I actually know what q to the power of 0 is. Anything to the power of 0 is 1, so I can read that y 5 equals p times 1. P times 1 is just p. So 5 equals p. I've gotten a good starting point. Now I'm not putting that one in second because it's got k and that's what I need to find out. I'm going to put this one in. So the same thing, I'm just going to substitute the values in and see if I can do anything with it. So I've got 405, which is my y value, equals p. I've got a value of p, so I'm putting 5, times q, I still don't know what q is, to the power of 4. Okay. We just start solving this. So because this is 5q to the power of 4, I'm just going to divide both sides by 5. Okay. 400 divided by 5, I'm going to trust my calculator. 405 divided by 5 equals 81. So we've got 81 equals q to the power of 4. Now, what we're going to do now is actually going to root these, both sides, to the power of 4. Okay. The same as if that was squared, I could square this, because this is to the power of 4, I can root it to the power of 4. Now you might need to find out where that button is on your calculator. In my instance, it's shift that one there. Okay. So let's just do this. It's 4 to 81. Okay. Which nicely gives me 3. So this then becomes 3. My right hand side, if I'm doing something to the power of 4, then rooting it to the 4, I've got q. So now I've got q equals 3. So I've got p and I've got q. Okay. Things are getting nice to work out. Now look at my 2k, and I substitute the values back in. I don't know my value of y, I'm just going to put k equals p, I've worked out to be 5, q I've worked out to be 3, to the power of x, x is 2. Okay. You could just put this all into your calculator, so 5 times 3 squared equals 45. So k equals 45. A lot easier than what you think. Right, it says draw a chord of a circle. Just go through some terms. All the way round is the circumference. From left to right would be your diameter. From the middle outwards would be your radius. A chord is it goes from one point to another point, but it's not your diameter. Right, there are only red and yellow sweets in a bag. 2/5 of the sweets are red. Write down the ratio of red sweets to yellow sweets. Now, if 2/5 are red, that actually means that 3/5 must be yellow. So the ratio is actually going to be 2 to 3. Work out 1.7 to power 3. This is calculator paper, so just type in your calculator essentially. 1.7 to the power of 3. On this calculator, the power of button is there. There is also a cubed button which is there, they're both fine. Okay, we've done like as a fraction, let's do it as a decimal. 4.913. If you want to do it another way, you could do 1.7 times 1.7 times 1.7 and you'll get exactly the same answer. There are 6 identical hexagons. 3 of the hexagons are joined to make shape A. The other 3 are joined to make shape B. Which shape has a greater perimeter, shape A or shape B? You must show how you get your answer. Now, essentially, we need a unit. I'm going to use a unit which I'm just going to call side lengths. Now, this one here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to say A has 14 side lengths. Right, B, which I'm going to change colour for. I'll say it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B has 12 side lengths. Okay. Thus, shape A has a bigger perimeter by 2 side lengths. Okay. Right, a bowl contains 1 apple, 1 banana, 1 orange, 1 peach. Just take 2 pieces of fruit from the bowl. Write down all the possible combinations of fruit Jess can take. Now I'm going to explain 2 ways to do it, but let's do it logically. Let's start with an apple. So I can have an apple and a banana. I can have an apple and an orange. I have an apple and a peach. Okay. Next thing, I want to start my banana. So I can have a banana. Now banana and apple is already there as apple and banana. So I can have banana and orange. And I can have a banana and a peach. Okay. And the last one I can have, we start with your orange. Orange. Now I can have orange and banana, apple is there. Orange and banana is there. So I can have orange and peach. And that's all my combinations. Now the other way we can do it, which might seem is a bit excessive, is that we can do it as a sample space diagram. So on the top I'm just going to put all the fruits. Apple, banana, orange, peach. On the bottom, on the side I'm going to put exactly the same. Apple, banana, orange, peach. I'm going to draw my table. Right, I'm just going to put apple, 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 banana, apple, orange, apple, peach, apple, banana that is, banana, banana, orange, banana, peach, banana, apple, orange, banana, orange, 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 peach, orange, apple, peach, banana, peach, orange, peach, peach, peach. And then we just cross out all the ones that we can't have. So I can't have apple, apple, banana, banana, orange, orange, and peach, peach, because they will double up. And if you look, my left-hand side here is exactly the same as my right-hand side. So I can actually just cross out all of these, because these all duplicate. And I've got all of these examples, which are exactly the same as the ones we've done there. Right, it says, on the grid, complete a diagram of a parallelogram. Now, a parallelogram has 2 sets of parallel sides. So if you think of this side here, we need a parallel side there. Now the parallel side will have the same gradient, but if you look, this goes along 3 and up 1. So I have to go along 3 and up 1, which is there. But it also means that the other 2 lines, this line here and that line there, should have the same gradient. And let's check, it goes down 3 across 2, down 3 across 2. So again, we just join it up. Right, you've got a diagram. Tom says A, B, C cannot be a straight line. Why is he correct? Don't say it's wrong because it looks straight. But essentially you need to know that a straight line adds up to 180 degrees. So 146 plus 32. It's calculator paper, so use your calculator. 146 plus 32 equals 178. And the key is to say a straight line must be 180 degrees. The first term of a sequence of numbers is 18. The term-to-term rule for this sequence is add 6. Is 603 a term of this sequence? You must explain your answer. Right, so let's actually write out this sequence. It will help us out. Right, let's start off with 18. 18 add 6 is 24. 24 add 6 is 30. 30 add 6 is 36. I've just drawn a couple I can work out with. Now I could keep going until I hit 603, or if I don't hit 603. Or we can do something smart. Now we can work out your nth term. Now nth term is that we look at your difference here. And your difference here is 6. And to be honest with you, it says it there. So it's going to be 6n. How do I get from 6 to 18? I have to add 12. So my nth term is 6n add 12. Now it's actually asking us, if I do 6 times a number, add 12, will I get to 603? So I'm doing 6n plus 12 equals 603. Right, 6n plus 12 equals 603. We'll have a solution. But if n's a whole number, then we can prove that it's going to be in the sequence. To solve this, I'm minus 12 from both sides. Okay, this cancels out. Means I've got 6n equals. Now, it's calculator paper, so I'm going to use my calculator for this, just to be safe. 603 minus 12 equals 591. And to solve it, I divide it by 6 divided by 6. Okay, which equals 98.5. Because that says 98.5, and that's not a whole number, we know it's not going to be in the sequence. So I run out of space here, but I have to say it's not in the sequence. Right, next bit. Recivi says no terms in the sequence are multiples of 7. Give an example where Recivi is wrong. Easiest way is just to keep going along in your sequence just to see if we do hit multiple of 7. Okay. Now, what was I? I was on 36, and it's going up in 6s. 36 add 6 is 42. And then ask yourself, is that in a sequence? Then add 6 again, 48. Add 6 again, 54. 6 again, 60. And ask yourself, is any of these numbers in the 7 times table? Well, the answer is 42 is in the 7 times table, so 42. Okay. If you wanted to show off, you can say the 5th term is a multiple of 7. Now, if you really wanted to be smart, what we could do is write a sequence, which is 6n plus 12. Now, if it's a multiple of 7, I could just times it by 7. Okay. Let's expand this. 7 times 6 is 42. Plus 12. Now, any value of n I put in will give me a term that's in the sequence that is also a multiple of 7. So if I put 1 in, I'd actually get 42. If I put 2 in, I'll do 2 times 42 plus 12, which is 96, which is also a 7 times table that's in the sequence. So your statement really is that all numbers that are times by 42 and then add 12 will be in the sequence and is a multiple of 7. Thank you. A road map has a scale of 1 to 50,000. The length of the road on the map is 8.5 centimetres. Work out the length of the real road in kilometres. Right, so if it's 1 to 50,000 and it's 8.5 centimetres, okay, we now need to work out what the actual measurement is. So I have to get my calculator. I put 8.5 times 50,000, which gives me 425,000. But this is in centimetres. Don't put down this is in kilometres because 425,000 kilometres is actually quite a long distance. Now, kilo means 1,000. So change your centimetres was 1,000 meters. So to change the centimeters into meters, we have to divide it by 100. So it's going to be 4250 meters. And to change this into kilometers, we divide it by 1,000, which is 4.25 kilometers. We don't have to round it, so the answer is 4.25 kilometers. Right. In September, Sharon paid £565 for some books. She sold all the books for a total of £780. In October, Sharon bought and sold some more books. The total profit she made in October was 13% greater than the total profit she made in September. In November, she wants to pay a bill of £30. Sharon thinks that the 13% extra profit she made in October will be enough to pay this bill. Now, this is a very wordy question, and I'll be honest with you, I think the words are confusing, but there's not really a lot to it. First of all, let's work out the profit. So she's £780 is what she earned. Yeah, so we subtract that from 565. So 780 minus 565, 215. Now, 13% greater than the total profit. Okay, so this is a total profit, and it's just 13% greater. So I like to draw my ratio bar. Okay, and it's just the profit. So 100% is going to be £215. Now, because we're talking about profit, it's tempting to think of this as a 13% increase, but it's not. It's just the 13%. Okay, so all I need to do is to find 13% here. Okay, now to work this out, these haven't got common factors, so I need to go via 1, so I'm doing a unitary method. To get from 100 to 1, I divide it by 100. And to get to 1 to 13, I times it by 13, which means do the same to the other side. I divide it by 100. Okay, now I don't trust myself, I'm going to use my calculator. 2.15 divided by 215 divided by 100 equals 2.15. Okay, here I times it by 13, so I times that by 13, which equals 27.95. Okay, so then your answer is actually no, Sharon is wrong. She only makes £27.95. If you want to show off, you can say thus she is, and let's just do 30 minus 27.95. Do a calculator. 30 minus 27.95, which equals £2.5 short. £2.5 short. Okay, to go through some features of this calculator, if you're doing a calculator exam. The first thing I want to draw your attention to is questions where it says graph. Now, there's nothing wrong with putting like -5 in by times in -5, then adding 1 for each of this, but your calculator can do a table of values for you. If you go to mode, and then you go to table, it says f of x. Don't be confused by the f of x, that's just, for all intents and purposes, a version of y. Type in 2x plus 1, so type 2. Now we do have an actual x button there, which means alpha x. I'll do plus 1. So your start value, now in my table of values it's going to be -5. End, it's actually going to be 0 for me, and this would obviously change, put on it. So press 0 equals, it says step, and that's the increments, which is 1. And I actually got my table of values there. So it's going to be -9, -7, -5, and if I scroll down, -3, 1, and 1. Okay, I can actually do it for quadratic ones as well, just in exactly the same way. So if I just press clear it, I can just do my x squared. So I'll use the same x, which is just alpha x, do the squared button, plus 3x, plus 7. It'll ask me the same questions. So -5, my end here is actually -2. Step up in 1. Okay, and it gives me it then. So it's going to be 17, 11, 7. Scroll down to get the next one. 5. Okay. You could do that for any graph whatsoever. To get out of it as well, it's mode and 1. So to get into it, you have to do mode and table, which is 3. Okay, mode and 1 to get out of it. Now the next bit is if you get a question that says list the product of the prime factors Now, the calculator can again do that. If I want to do 310, I type in 310. I press equals. Now above your, like this one here says commas, you've got a button that says FACT. So shift FACT tells me 2 times 5 times 31. Now let's say it's giving you a stupid number, that's 3,600. I'll do 3,600, press equals, fact is there, so shift fact, and again gives me it as 2 to the power 4, 3 squared and 5 squared. Okay, next bit I want to do is 7 to the power of 0.5. Now some of you might not know what a decimal index is, or a fractional index is really what we do, but don't worry, if it's on a calculator paper we don't need to. I've got a squared button there, okay, I've got a cubed button here, but this one here is x to the power of anything I want. So if I do 7, you can see it goes up a little bit. And if I put 0.5, gives my answer of that. Okay. Right, next one I want to do is 23% of 79. Now a lot of people know where that percent button is. Okay, it's up here in front of your brackets. So if I do 23%, of in maths means times, so times 79 equals 18.17. The fraction button, again, is here. So you do 3/5 plus, and again it's there, which is press your fraction button first, 1/7. Does do it for you. It will make it in its lowest terms. Now the only difference is between the bottom one and the top one. Now if you want to put like a mixed number in, you actually have to use the fraction button that's on the top. Okay, so I'd have to shift, and then you get 3 boxes. You're going to put 2 and 3/7. And the question is plus, and I have to shift in that again, 1 and 4/8, and there you get it. The difference between using this button and going back to get a fraction and doing a shift button. Now for example, let's say I do 1 and a half. Oh fuck. Let's say I do 1.5 plus 1.5. Now you should know that's actually going to be 3. Okay. Now my calculator is telling me it's 1, and that's because what you've told your calculator to do is to do 1 times a half plus 1 times a half. If you want to do it properly, you have to do your shift button. We're going to do 1.5 plus 1.5. There you got 3. Now the last one is just trigonometry. Now you do need to know a bit of trigonometry rules, but the only thing before you even start doing that is to make sure your calculator is in degrees. Now at the top it says D, okay, which means I'm okay. But there are other situations where you can have like rads or grads. Let's say I'll do this. Now if it says RA on the top, every trigonometry question I do will be wrong. So we need to make sure that that's actually on degrees. And I say it's shift and mode, and then 3 for degrees. Okay. Thank you. And generally, if anything's wrong with your calculator, just press mode on 1 and it'll be okay.